function transformation of exponential function, the parent function that I will be using is f of x equals to 3 to the x. So for each graph, I will do some transformation based on 3 to the x. Before we start, function transformation is very confusing. Do you see that in each graph I wrote so many things down and there are so many curves? Don't just sit there and watch my graph and expect you can do it. In fact, I expect you to download Decimal. You can look it up on Google. You can look it up on in Play Store, App Store. It's free. Just download it. Whatever graph I gave you, so each picture I gave you 3 graphs. Graph all of them in the same XY plane. Look around, see how the function shift up and down, left and right. All right, so starting on the first function, I have 3 to the x, so this is the red function right over there. So what happened when you add 2 to the 3 to the x? So when you add 2 to 3 to the x, the plus 2 is you shift the parent function 2 units up. So from 0, 1 to 0, 3. What else do I notice? I also notice that for the parent function, I have the horizontal asymptote at y equals to 0. So if when you add 2 to it, the horizontal function is now right over here. That is at y equals to 2. So what happened when you subtract 4 to the parent function? When you subtract 4, you shift the function 4 units down from 0, 1. So 1 minus 4, the y value will just shift down to negative 3. And also, the horizontal asymptote shift 4 units down as well from the x-axis, which is y equals to 0. Now, is at y equals to negative 4. That is where the horizontal asymptote is. So in summary, when you add a number right next to the exponential function that shift the function up, when you subtract a few units right next to the parent function that shift the parent function down. On your decimal, I hope that you are playing with your decimal right now. Change the plus 2 to plus 6, plus 7, plus 10 to see how does that shift the function. Change the minus 4 to something else, to minus 2, minus 5, minus 7, minus 8 to see the function shifting up and down, up and down. That is what I expect you to do on decimals. Okay, moving on to the picture on the left, we have right over here. So what do we have? I have a parent function, 3 to the x. So this time I also add and subtract. So this time I add 2 right next to the x and minus 4 right next to x, not to the entire function, right next to x. Okay, what happened when you add 2 right next to it? So when you add 2 right next to it, you shift the function 2 units to the left. So from the y asymptote from 0, 1 to, it's not from 0, from 0 to a negative 2. That is 2 units to the left. So from this place to this place, from 0 to 2, negative 2, that is 2 units left. Does that change the horizontal asymptote? No, we are shifting the function left and right. That doesn't change the horizontal asymptote. The horizontal asymptote remains as y equals to 0. So instead of subtracting 4 units to the entire function, I just put a minus 4 right next to the x. So when you do that, you shift the function 4 units to the right. So the y-intercept was at 0, 1. Actually now is no longer the y-intercept. So from this, you shift 4 units to the right from 0, 1 to 4, negative 1. So you have a point right over here, right? From here and then to 4, comma 1. 4 units to the right. And then since we didn't change, we didn't go up and down, the horizontal asymptote remains as y equals to 0. All right. Now, what I expect you to do is, on your decimal, change the plus 2 to try plus 1, plus 5, plus 6, plus 3, plus 10, so on and so forth. For the minus 4, try minus 1, minus 3, minus 5. You have to do a lot of looking. You have to do a lot of graphing, and then you have to do a lot of looking. That is how everyone study function transformation. Because if you just look at the image I gave you, it is pretty confusing. I'm sure that at the end of this video, you are not going to retain any of this information. You need to do some work on your own device. All right, so we have 2 graphs on the bottom. This one is still based on 3 to the x, and then the horizontal asymptote is y equals to 0. Okay, let's take a look at what I did. So this time I add 2, so compare this I add 2, so this time not only plus 2, I also plus 4. How does that change the parent function? So if when you add 2, you go 2 units up, the 4 is 4 units to the right. So the parent function has a y asymptote right over here. So now you have to go 2 units up. So you have to go from 1 to 3. That is 2 units up. And then at 3, you have to go 4 units to the left. So that is right over here. So here is the path. Let me draw another arrow for you. So first, you go 2 units up right here. You go 2 units up. And then you go 4 units left. So 2 units up and then 4 units left. Does that change the horizontal asymptote? Of course, because you shift the function up, the horizontal asymptote was at y equals to 0. So since you push that 2 units up, so now the horizontal asymptote is at y equals to 2, which is right over here. How about the green function? The green function, I also plus 2. Plus 2 means you shift the function 2 units up from 0, 1 to 0, 3. That is 2 units up. And then there is a minus 4 right next to x. That is 4 units to the right. So you go 4 units to the right. And then you are at 4 comma 3. Right? 4 units to the 2 units up and 4 units to the right. And then how does that change the horizontal asymptote? Of course, you push the function 2 units up. So it was at y equals to 0. Now it's at y equals to 2. You might want to ask me, hey, how do you get the points? Negative 4 comma 3, positive 4 comma 3, how do you get it? Because on my graph, the decimal, I don't see it unless I point at that location. So here is how I got it. Do you see that on your decimal, on the upper right hand corner, there is a gear symbol? Click on that, click on the gear, and then you should see somewhere on that page, there is a table symbol. Click on the table and then input the x value that you are looking for. So let's say x equals to 4 or x equals to negative 4, and then decimal will calculate the corresponding y value for you, and they will also plot that point for you. Right? So on the table, just input x equals to 4, so for the green function, you have to input x equals to 4. For the purple function, you input x equals to negative 4. Decimal will calculate the corresponding y value, and then they will just show you where the point is. They will give you a point, so once you click on the point, they will show you the xy coordinates. All right? So moving on to the picture on the right, we have 3 to the x, still at the same place. Horizontal asymptote is y equals to 0. So this time I subtract 4 for the purple function, that is 4 units down, and then I add 5, that is 5 units to the left. So here is how the shifting is done. So 4 units down right here. 1 minus 4 is negative 3, and then 5 units to the left, 0 minus 5 is negative 5. So 4 units down, 5 units to the left. And then it was at 0, 1. So now the point is shift to negative 5 comma negative 3. Does that change the horizontal asymptote? Of course, because you push the graph down, it was at y equals to 0. Since you go 4 units down, now it's at y equals to negative 4. Okay, so I should write this down, the horizontal asymptote. So horizontal asymptote now is at y equals to negative 4. Same thing for the green curve. For the green curve, you shift these 4 units down and then 6 units left. So 4 units down, 1 subtract 4 is negative 3. 0 plus 6, 6 units to the right becomes 6. 4 units down, 6 units to the left. Okay, so that is the second picture. On your decimal, don't just graph what I gave you, change the numbers around. So you have your parent function, change the minus 6 to minus 7, minus 4 to minus 5. Just change the numbers around, all right? Okay, we have 2 more graphs. we have two more graphs. The next one, parent function, is still 3 to the x. So what happens if you put a negative sign in front of the entire function? So 3 to the x, 3 multiply itself a few times is always positive. Once you put a negative in front of that, that makes the function always negative. As a result, that creates a reflection in the x-axis when you put a negative in front of the entire function. Now, what happens when you put a negative right next to x as the next transformation? So when you put a negative x, that creates a reflection in the y-axis, because in the negative 3 to the x, when x is equals to negative, y is equals to positive, right? So you have when x is equals to -1, you have a -1/3. But if you put a negative sign right next to x, so once you pick negative, the minus negative becomes a positive. So as a result, that creates a reflection in the y-axis. And then the last one, the parent function, is by the way, for all these functions, the horizontal is y equals to 0. For the green function, as x goes to positive infinity, y goes to 0. For the blue function, as x goes to negative infinity, y goes to 0. All right, and then the last one, you have your parent function, and then what happens when you put a negative in front right next to the x? So that creates a reflection in the y-axis. The function becomes a decreasing function, because when x is equals to what? When x is equals to 1, you have 3 to the -1, and then that will bring the entire term to the denominator. So as you pick a very large value for x, you are going to create a large denominator. As a result, the y value is very small. And then you put a negative in front of the entire 3 to the -x, then that creates a reflection in the x-axis, because this is always positive, right? So this one is always positive. It doesn't matter what x value you choose. But once you put a negative in front of what is positive, then you make that becomes always negative. All right? So that is the end of this video. So once again, in your decimal, change the numbers around to see how the graph shifts. Don't just look at what I gave you and believe you can do your homework. Okay, so that is the end of this video. If you like the way I explain function transformation, give me a thumbs up, give my channel a subscribe. Truly appreciate your support. I will meet you all in the next video for more math content. Signing out.